Hello and welcome to today's Partner Web Conference. This is Fast Track Dynamics 365 for Finance and Operations Enterprise Edition Tech Talk. Today's topic, Extensibility. Presenting for us today from Microsoft, we have Principal R&D Solution Architect, Zach Greenvoss. So without any further delay, Zach, welcome and thanks for joining us.
Thanks, Janice. Hello, everyone, and welcome to this Tech Talk on Extensibility. My name is Zach Greenvoss. I'm a solution architect with Microsoft. Today, I'm going to be walking you through the various extensibility options available in Dynamics 365 for finance and operations. Now, this is actually a refresher of the previous extensibility Tech Talk we did last year. This talk will highlight some of the new technologies available as of Platform Update 20. So, let's first take a look at what we mean when we really are talking about app sealing. So AX, from early on through 2012 and into the AX7 release, has always allowed customers and partners to have a high level of customization of the source code and business logic. This was typically achieved through a technique called overlayering, wherein partners made changes to the Microsoft-provided source code directly in line to the existing code. While very useful and a boon to partners and customers looking for the ultimate flexibility in defining business processes, it has proven to be very difficult to manage the upgrade process for code that has been customized in this way. Updating the code to get a hotfix or uptake an ISV solution often involves an entire new project with costly development fees that is prone to errors and additional bugs. Ultimately, this caused our customers to not take important updates and hotfixes. Now, this is especially challenging in the cloud world, where we need to issue updates at a faster pace. The ultimate goal is for us to enable our customers to have a true cloud solution that provides a platform that gives easier and less expensive upgrades and updates. The bridge that will enable this transformation to happen is extensions. By expanding the extension capabilities in Dynamics 365 for finance and operations, we are enabling partners and customers to continue to build vertical solutions that add value, but that do not directly interact with the Microsoft source code in a way that makes it difficult to upgrade the solution. Here's another view of the same goals. The ultimate goal is to improve the quality of the solution and to allow customers to have a continuously updated and improving platform. For Microsoft partners, they should be confident that the solutions they build will continue to work and bring value to their customers no matter what updates and changes are made to the core product. Some additional benefits we see with moving to extension-based customizations are a looser coupling and improved testability in both Microsoft and partner solutions. Also, by moving code away from the larger Microsoft models, partners can enjoy much faster build times and a more efficient application development lifecycle. Finally, the actual distribution of solutions is more lightweight and streamlined in this model. I just want to take a moment here to ensure we're all on the same page. The example on the left is what I mean when talking about overlayering. There is the core application suite provided by Microsoft, which has been directly extended by multiple ISV solutions and a partner ISV solution to tie it all together. Now, this entire set of code is compiled into the final application assembly, and any changes or hotfixes needed to be merged across all four solutions. Now, the extension-based solution on the right is where we are moving towards and where we are with the 8.0 release. In this, the Microsoft-provided application suite assembly is isolated from changes and is only modified directly by Microsoft-provided hotfixes. The ISV solutions and the VAR solution are also deployed and maintained as discrete assemblies. Extensions to the models are hosted internally to these assemblies through the techniques we will discuss in this Tech Talk. This model is easier to update and able to handle changes to the solution over time in a more agile and fluid way, as the interfaces are well defined and any components can be swapped out or upgraded when it makes sense for the business needs. Now, as of this new Extensibility Tech Talk in October 2018, we have sealed the entire application. This diagram really shows the history as we raise the bar from the platform into the application suite. As of the spring release 2018, also known as 8.0, we no longer support any overlayering across the Microsoft models. all customizations must be done through extensions. So now that we have a good idea of how critical extensibility features are for customizing Dynamics 365 for finance and operations, let's take a look at exactly what these features are. At the core level, an extension is just something that augments or adds to the capability of another object. As discussed, these additions can exist in a separate model entirely, thus allowing partners and ISVs to keep their changes isolated from each other and Microsoft. We will be discussing these capabilities in detail, the ability to add new model elements to the solution, and the ability to modify or augment existing model elements. This will also be referred to as metadata extensibility, as we are modifying the metadata of the various elements in the solution. Finally, we will spend quite a bit of time exploring the underpinnings of how to augment source code. There are several options here, each of which can help address some of the capabilities that overlayering provided. An extension model provides the ability to add any of the elements that are available in a typical Dynamics 365 solution. So new classes, forms, tables, and EDTs can all be added and managed as a complete separate solution built on top of Dynamics 365. Now, I think this goes without saying, but this should always be your first choice if possible. If you can isolate your development and only produce a solution that is additive in nature to the core product, you'll be safe from any product changes in ISV interactions. Obviously, this is not realistic for all solutions, but when possible, this should be examined as your first choice. In terms of metadata extensibility, the things you can change really depend on the type of model element you are augmenting. We'll walk through what is possible, but in general, the types of changes you can make are adding new fields or UI elements, hiding and modifying existing UI elements, and adding data sources and Enum values. Note that by and large, this is still a fairly additive list, though there are ways to make changes to the base elements. From the X++ side, there are several ways to hook into the base application and run your code. Through some powerful extension capabilities added to X++, we can add methods and state to existing classes, and we have the ability to hook into a wide range of framework events and delegates. Now, this list continues to grow with each release as we expose more of the system to this model. We are also working hard to refactor any object model that requires overlayering to add derived classes into a plugin-based solution, which means you can add new classes without touching the base code. And finally, we have the powerful capability to write code that can wrap the base Microsoft code and update and change the state of the system, as well as the input and output values. This, plus delegates, will be the core technology that allows you to replace the X++ overlayering. Yet, it is completely ISV and upgrade safe and allows multiple partners to participate in extensions without adversely impacting the upgrade story. The next section of this talk will be a deep dive into the metadata extensibility features as of the 8.1 release and Platform Update 20. Some of this might go fairly quick as there is a lot to cover, so I encourage you to utilize the recordings of this talk and go back to review specific areas in more detail. I will be calling out newer functionality that has landed as of Platform Update 20. So first, we're going to take a look at what's possible with form extensions. Forms provide a rich set of metadata extensibility. It's possible to add new controls to a base form through extensions, including the ability to disable or hide existing controls. Now, this is how some partners are customizing certain elements that might not otherwise be extensible. They will hide that section of the UI and add their own controls into the solution. There are some basic UI manipulations you can do, and you have the ability to add entirely new data sources to the form, which then allow you to make use of that new data. The data source can be from the base application or a new table added as part of your extension package. Now, new as of PU20 is the ability to change a form's pattern to custom, thus enabling new form controls to exist where they might not have been allowed previously. We have also unlocked the ability to customize the key workflow properties of forms, thus allowing you to enable workflow on forms without requiring overlayering. Much of what our partner solutions need to be able to do is access the rich eventing and object models behind the forms. In this, you'll be using the various code augmentation features in an extension project. Forms provide several layers of events, from the form itself to the data sources and the controls. Some forms could also support custom delegates raised from X++ code. All of these are capable of hooking into via your extensions. Now we have all the various events documented at on our docs site. Many of these events have preceding events and succeeding events, but not all. When we do have both events, the preceding event will end in ing and the succeeding event will end in ed. Depending on exactly what you're trying to accomplish with your extension will determine exactly what event you hook into. Now here's an example of an event handler on a form. We'll talk about this in more detail later, but this code does not actually need to live within a class that is specifically extending the form itself. The attribute is what ties the event handler to the event publisher. Thus, this code can exist within any class in the system, as it's a static void method. From within this event handler code, you have access to the original form. It can write code that you typically might have written directly as an overlay layer within the form itself on a previous version. Now, a powerful feature available in powerful feature is to utilize the chain of command technique. This allows you to wrap methods in your own logic, or provides you the ability to write that same pre and post event handlers, as well as gives you access to protected member variables and methods. Now there are new capabilities exposed in Platform Update 20 that make this even more useful for building solutions around forms. We will cover these in detail later in the talk. Here's an example of an extension class on the sales table form where we are wrapping the update design method. The key takeaway here are the attribute that defines the class to be an extension of the form and the call to next within the method itself. This is where the chain concept and chain of command comes in, as it is possible for any number of ISV and partner solutions to wrap this method, and each will be invoked in a chain until the base code is called, at which point the execution is unwound and returned to the caller. So in this example, I'm adding code after the core call and updating the UI based on a custom enum value I added in my extension project. A core part of any solution is data, so it's important that we provide the ability to extend tables in Dynamics 365. Let's walk through some of the options available for table extensions. As with forms, much of what we support from a metadata perspective is additive. We can add new fields, new indexes, new relations, even new fields to an existing field group. In terms of changing the table metadata itself, we can change the label of a field, change the if created and modified fields are included in the table, and change the EDT of a field, but only to a derived EDT of the base type. Essentially, you can make the field be more specific, but not entirely change the data model. A new property that is supported as part of our GDPR compliance is the asset classification of a field. This can now be modified or changed in an extension. Unfortunately, there are some things that are not currently supported. It is not possible to change the cache lookup or the storage mode of a table via extensions. In addition, indexes cannot be modified. The concern is that allowing this type of change would break existing Microsoft business logic. Now, tables support a large number of events that extension code can hook into in order to have a view into the life cycle of a record. Again, these events largely come in pairs with preceding and succeeding events raised. Exactly what to hook into will depend largely on what customization you are trying to accomplish. We publish the full list of events on our docs site, but just to give you an idea of how they map out, I have copied some of them here. As you can quickly see, the event ending in ing is the event that precedes the method, and the one ending in ed happens after it is completed. So, for example, if you want to hook into some code to the insert method, you can utilize the inserting event to write code before the insert, and the inserted event to write code after the record is already committed. Now, there are more events than this, including a set of events specifically related to data entities and validation that can be very useful. Now, we have examined the ability to modify forms and tables, which, alongside classes, are the vast majority of where our partners and customers extend the system. We will examine a few other objects that support extensibility in the system, starting with views. Now, views are supposed to support much of the same functionality as table extensions. However, currently, the only supported features are additive. You cannot change the label or help text of a field, for example. You can add new fields and new data sources. And new, as of PU20, is the ability to add entirely new ranges to a view, which can dramatically alter a view's definition. Note that adding a computed column is also not supported, but is still planned for an upcoming platform release. Data entities support a set of metadata extensions closely related to views. As with views, the changes you can enable through metadata extensions are through adding new features. You can add new mapped or unmapped fields, field groups, relations, and ranges. You cannot change the properties of the actual data entity itself. Now, there are a set of extension requests that are often asked around data entities, such as the ability to enable them for OData or DIXF. Unfortunately, these types of customizations require additional testing, and if you need to make these changes, we recommend that you create your own data entity covering the required data elements and take ownership of the testing yourself. As of right now, none of these features are supported as part of the extensibility model. Data entities provide a wide range of events, much like the underlying tables themselves. Subscribing to these events is identical to the process of subscribing to form and table events. Like the table events, these generally come in pairs, with a preceding event ending in ing and a succeeding event ending in ed. Now, new with PU20 is the ability to write extension classes against data entities, and thus implement chain of command wrapper around data entity methods. Now, this can even include methods that are not implemented in the target data entity. So unimplemented base methods are possible to add via extensions. So let's talk next about enum extensions and what is necessary to add new values to an enum. In order to create an extension and add values to a base enum, it must be marked as is extensible. If this is true, then you can create an extension and add additional enum values to support your solution. So you might ask, why don't we simply have all enums set this property to true and allow you to extend any enum in the system? Now, we actually have done several big pushes from the R&D team to enable the is extensible flag on as many enums as we can. I think it's informative to understand the logic behind the decisions as to when we can and cannot mark an enum as extensible. This would be especially useful to our ISV partners who are exposing enums and might want to enable them to be extensible as well. So the first rule to understand with extensible enums is that you cannot write code that directly depends on the value, such as comparing the values in a greater than or less than operator. The reason for this is while the base enum values are deterministic and set by the system, the extension values are generated at synchronization time and thus are not guaranteed to be any specific value. Depending on other solutions that might be extending the same enumeration, the actual values are environment specific. So here are the guidelines for creating an extensible enum from the product team. This is closely related to the previous slide. Basically, you cannot use the values in any sort of comparison or range. This is why some enums in the core product cannot be currently switched to an extensible enum, because they make use of these comparisons heavily, such as the status issue or status receipt in the inventory area. Another common issue with enums is that they are used in a switch block, and the default case will throw an exception, thus making it impossible for a partner to provide their own value for the enum. Thus, before marking an enum as extensible, it is necessary to ensure any switch statements on the enum are either hookable, via chain of command, or have a delegate to allow partner code to hook into the logic. Also, if the enum switch statement is used in a constructor or factory method, the general best practice guideline is to create a set of classes annotated with the sys extension attributes, thus enabling dynamic creation of classes based on the enum values, including extended classes from partners. So here's a specific example from the product team. Prior to the previous spring release, the BarcodeType enum was not extensible. When the product team wanted to switch this flag, they found this construct method utilizing a fixed set of enums with an error message thrown if the correct enum was not found. Now clearly, this enum cannot be marked as extensible. So in the previous spring release, it was switched, and this is the code that's in the product now. So this is now utilizing the sys extension framework to get the correct class from the attribute, thus allowing a partner to extend the enum for a new barcode type. They would need to implement their own class, implementing the specific barcode implementation logic, and annotate it with that new enum value. To support the previous code, the existing barcode classes were annotated with the barcode type values, thus creating a dynamic and flexible mapping between enum values and classes, instead of the static factory method used previously. So EDTs are also extensible in the Dynamics 365 for finance and operations. So EDTs support a limited number of metadata property extensions. The primary reason most people extend EDTs is to increase the string size of a field. Now we also have the ability to change the number of decimals for real types. However, this is only supported for a fixed number of EDTs. From the Microsoft side, we need to ensure the code consuming these EDTs can handle the arbitrary number of decimals. As of 8.1, the release 8.1, this is the list of EDTs that support extensible number of decimals. We will be adding additional EDTs based on customer feedback. We'll just touch briefly on query extensions. Query extensions support the ability to add ranges or embedded data sources, which can effectively change the query selection logic. You can also add fields to the query from the existing data sources or new ones you have added via an extension. And new, as of PU20, is the ability to add a new root data source. You couldn't do that previously. So menu and extensions are a way for you to inject your own structure into the application. You can extend both menu objects as well as menu items. At the menu level, you can add additional sub-items as well as hide existing menus or menu items. This way you can hide existing functionality and replace it with a new menu item pointing to your solution, for example. Menu item extensibility allows you to point the menu item to a different object or report, as well as change the label and a handful of other properties. Security roles and duties also support extensibility features, albeit somewhat limited in scope. You can extend security roles and duties, but the only changes possible are adding new duties or privileges. There are no removing or modifications possible. So let's talk about creating reporting solutions. So first, the bad news, and this hasn't changed since the last time. We have not figured out how to make SSRS reports extensible in the true sense of the word. There's not currently a way to simply right-click on an SSRS report and extend it in your own package with your own data and designs. However, we have many of the necessary components for a reporting solution in place. We can extend the tables necessary to add new data elements to the system, as we discussed previously. We can extend the data provider class that populates the necessary data set with new data elements. And we can extend the menu item and/or report controller class that launches the report to point to a custom report. Now, the custom report itself will be a copy of the original report with the extension-specific changes added in. So this is a depiction of the different models at play. The application suite hosts the original table and report data provider class. We have a custom model. This could be an ISV or a bar model, which has appended new fields via a table extension. and subsequently wants to display these on the report. The report data provider is extended to query the new fields and populate the data into a custom report that was copied from the standard base report. Now at runtime, this report is executed and the customer sees the new fields as they would expect. Finally, we have labels, which is possible to extend with label extensions. Now, label extensions can modify existing labels in the system as well as add new ones. We also support the ability to add new languages to existing label files. Now, when you add a new label to the system, a wizard will prompt you for information. To build an extension on an existing label file, you just need to use the naming convention of original name _ extension. It is possible to have multiple extensions on a label file. In this case, you're going to append an integer to the extension string, such as extension 1, 2, etc. And that wizard will also allow you to add new languages. All right, so we've examined some code already, briefly throughout this talk, but now we will focus specifically on the capabilities in X++ to augment and extend classes. Note that much of this applies to forms and tables as well, which ultimately have X++ classes backing them. So we will look at the following topics in more detail. Event handlers and delegates are closely connected. We will look at how these can be used to respond to events in the core application. We will look at the pre- and post-handler methods briefly, and finally dive into the true extension model and the chain of command technology. Now, I'll tackle this question that often gets asked around all of these types of extension points. There is no way to guarantee an execution order if there are multiple event handlers or delegates. The handlers are called in an indeterminate order. Now, if you are the only code executing on an environment, it can be tempting to believe you will know the order that events will occur in and make some assumptions about this order. However, as soon as another ISV or partner solution are added to the mix, your events could be executed in a different sequence. So just keep this in mind across all of these techniques. So events can be raised from forms, controls, data sources, tables, data entities, as well as a number of other areas. Now these events can be handled by code running in an extension model by copying the event handler method and writing code in an event handler class. Note that this code does not need to be running in an extension class. Now, here's an example of event handler residing within an extension class of the underlying table. Since the event handler method is static, it does not benefit from the extension capabilities unless you added static member variables and methods. In general, the recommendation is to create an event handler class that can contain the event handlers and call out to other objects as necessary. Now, the parameters of an event are always generic and must be cast to the specific types. The exact types depend on the underlying object and the exact event being raised. Now, this is an example of a table modified field value event. So we are passed the table buffer as the first argument and a modify field value event args parameter as the second. Now on the Microsoft Docs site, we have a full list of the events and their argument types. I recommend using this heavily when building any solution utilizing eventing. So besides the arguments being generic and must be cast to a specific type, you are also running within a static method and only have access to the parameter data that was passed to the event handler. By definition, this means you only have public access to the underlying objects and cannot access the private or protected class members. Now, if you need to get access to the form controls, you can use the element keyword or the xFormRun design method, which is what I'm showing you here. And then from the design method, you have access to like the control name method, which you can then get access to what you need. Another way of accessing the form methods and controls is shown here. By casting the xFormRun parameter to a formRun variable, we can now invoke methods that are available at runtime. Thus, we can call methods that we have added to the form ourselves via an extension class. You can see here I have an extension method to return a specific control, which I can then access via the formRun variable. Another common ask is how to get access to the data sources on a form from an event handler. As you can see in this event handler, we can get access to the data source via the form control form run method. I have sender.formRun as the method, and then I have access to the data source. Delegates are another type of event that can be raised from code. These are typically inserted into X++ classes when it makes sense for partner code to execute within the flow of an existing X++ method. In this case, even the chain of command technology will not help because you need your code to run inside of the Microsoft logic. In this case, the only option is to raise a delegate and write event handler code that responds to that delegate. You can see all of the delegates on a class by viewing that class in a design view. Then you can copy the event handler boilerplate code just as you did with events in forms or tables. And again, the event handler can be copied into any class. The mechanism that ties this together is the attribute itself. Depending on the type of delegate, the parameters could be very specific to the scenario. Now, at a high level, there are two major classifications of delegates in the system. The first is a publish-subscribe pattern, but there is not an expectation or even a possibility of the subscribing code to affect changes in the base code. Now, this is primarily used as an eventing system, such that partner and customer code can execute at the correct times over the life cycle of the application. So one example of this I'm showing here is the application startup delegates, which provide some events on the application lifecycle. The other major classification is the request response delegate type. In this, we do expect some sort of response from the partner code. It's codified through the event handler result reference parameter. Here's an example of requesting the extension code to provide some information in order for the base logic to continue. The pattern here is that the last parameter on a request response delegate is always the event handler result object. As you can see in the code, this is checked to see if any subscribers have set the value via the hasResult method. In this way, partner and customer code can hook into the base application and make changes in a type-safe and supportable way. So here's another example of a delegate used to get information from the extension code. We talked earlier about extensible enums and switch statements. This is an example of providing the delegate so the extension code can respond with extension enum values. As such, the event handler result is used to return the result to the base code. Note also that the code has requested that only a single response is valid. Thus, only a single subscriber to this delegate can set the result. Otherwise, an exception will be thrown. You also have the ability to write pre- and post-handler code on any public or hookable method on any X++ code in the system. Hookable is an attribute that can be placed on a non-public method to allow the pre- and post events to be written against it. Now, in general, we believe the chain of command is a better technology for extensibility. With pre- and post event handlers, you have the restriction of only external or public access to the objects, and everything must go through this non-type safe methods of the XPP pre-post args parameter. In general, this is a deprecated technology, I would say. So class extensions are a way to augment X++ classes with new methods and new member variables. From an object-oriented point of view, it's a bit like deriving from a base class, as you get that level of access to the extended class. However, the client code does not need to be changed to utilize your new derived class. The new extensions automatically augment the existing objects. This can be very powerful, especially when combined with the chain of command technology that allows you to wrap existing methods and write your code before and after. So class extensions must end with the suffix _extension, and they must be decorated with the extension of attribute. They also must be marked as a final class, as there is no option to derive from these. We recommend including a unique prefix in the name. The name before the _ extension does not need to exactly match the original class name. the actual mapping is done through that attribute. Any new methods added via this extension class will be visible to client code that has a reference to the extension model. You can see here that I've added a new method to this ftTotalsEngine class. So the key components for extension classes are these keywords here. You have to decorate any extension class in this same way, although depending on exactly what you are extending, the data inside of that extension of attribute will be different. So as I was saying, any methods added in this manner will show up as part of the available methods for this class. If I create an object of type ftTotalsEngine and I check to see what are the available methods, my extension method will show up as if it was just one of the possible methods for this class. Extension classes can also add new member variables with access modifier of public, private, or internal. So protected is not allowed. This state can then be used in the extension methods or client code if it's public. So this new member variable added to the core class, which is then usable via any extension methods added in this extension. A nice advantage that class extensions have is the ability to see protected members, both variables and methods. Now, private data is still hidden from extension classes, but extension classes now act like a derived class in that they have the same level of access to the protected state. So here we can see an extension class on the sales, packing, slip, journal, post class, which has the sales line as a protected member variable. Thus, in my extension class, I have access to this member variable, and it can write code to access it. So this finally brings us to the chain of command technology, which was introduced in Platform Update 9. This allows you to declare a method in an extension class that is an exact copy of the extended class method. The parameters must match, and if there are any defaults specified in the base class, they should not be set in the extended class. This technology will allow you to write code before and after the base code, which is invoked via the new keyword next. Now this next call is analogous to calling super in a derived class. It will call into the chain and invoke any other extension code that is hooking into this method, finally terminating with the Microsoft base code. Your extension code will eventually pick up the execution again and can continue after the base code, making use of the return value and performing any additional logic, up to and including changing the return value. So this that I'm showing you here is an example of a real use of chain of command. We wanted to be able to have MRP treat negative quantity as 0. This way, retail stores which have a negative inventory won't inadvertently order more stock than necessary. So the best way to solve this was with this very simple chain of command around the recalc init trans from invent sum method. You can see that we first invoke the chain with the next keyword, which runs the base Microsoft code and returns the standard rectrans object. We then check this value for our condition, namely, do we have a negative quantity, and change the rectrans value to 0 in that case, before finally returning the new modified rectrans. In PU20, we now have the capability to wrap methods in an extension class that were never implemented in the base class. Now, this was a common ask, especially around implementing methods on forms that were not in the base form, the most common of which was the can submit to workflow method. Now, this sample code shows how this can work. Note that it basically just looks like a normal extension chain of command code. So basically, it's now possible to implement any of those override methods that show up as possible when you right-click on a form, but you can now implement them in an extension class. Another major change in PU20 is the ability to implement extension classes and chain of command on embedded classes. This means it is now possible to write extension code on data sources, data fields, and controls, which are all represented as embedded classes on a form class or in a form class. So here's an example of customizing the validate write method on a specific form data source. Now, this was not possible before PU20. So for each of the different embedded classes, you will need a separate extension class. Depending on the type of object you are extending, you will use different values for the extension of attribute, either form data source string, form data field string, or form control string. This slide shows you the basic format of each. As mentioned earlier for forms, it is also possible to add methods that are not implemented in the base class. This example shows how you can hook into control events, even if the original control did not handle this event. Okay, so let's talk a bit about building extensible code. We've taken a fairly exhaustive look at the extensibility features in Dynamics 365 for finance and operations. So what happens if your solution has requirements not fitting into any of the techniques I've described? In this case, we have to have a discussion around intrusive customizations. Since AX as a platform has been so flexible in the past, we find that the expectation is such that any changes and modifications to the core logic of the system should be allowed. In a world where we only allow customizations via extensibility, this is no longer true. Some of the things we are not likely to allow are changing the method or type definition of our application objects. These define the contract of the system with our partners, and as such, allowing them to be mutable is very challenging to support in a cloud-first world. We're also not likely to support direct embedded SQL changes or inline code, as this is exactly the overlayering model we are moving away from. The general guidelines are to be additive in nature and to not break encapsulation or object models. So types themselves, such as classes or forms, are referenced by their definition, and changing a type's definition represents a breaking change to the code that might be relying on those types. And it's very difficult to support that in a world where we are updating the system more frequently, and we are demanding that we can support binary compatible versions moving forward. As such, we have to keep types, and what represents a type needs to be consistent. So as I was saying, what determines a type for either a class or a form are all these things: method signatures, their interfaces, the abstract class requirements against them, the access modifiers of the methods themselves, and even constraints on the tables, which is one of the reasons you see us not allowing the index changes on tables. So in general, the guideline is that we cannot break encapsulation. We have published an API as per the 8.0 and 8.1 releases, and we must encapsulate any changes sort of below that level of those API, which is essentially the type definitions. So in general, we cannot elevate access modifiers, such as bumping things from private to public, otherwise we would lose that encapsulation. And again, in general, we believe in this principle that our classes, our objects, our system should be closed for modification, but it should be open for extensibility as per sort of good object-oriented design practices. So for your functionality, you must be thinking about being additive and adding to the overall solution in Dynamics. So if you are adding a solution on top, you should be thinking about how that solution can add to the core business logic and not remove what the Microsoft code is doing. And you must obviously test, and you must not change the standard design, including performance. Right? So this is something that we require that you also test any of your changes for performance impacting changes as well. Okay. So given all of that, and given all of the techniques we've talked about so far, it is still possible that there are areas in the application that don't support what you need. So extensibility, all the features that we're talking about, is not as capable as overlayering, right? So even with the powerful chain of command feature, we see probably 80% of overlayering requests. We can already support those. And it's a very powerful technique, it's a very powerful language. However, there are features that are not currently possible. So what do you do then? What do you do in that case? So we have added tooling within LCS to capture extensibility support requests, right? So either you as a VAR working with the customer, or you as an ISV will have an LCS project, and you will come in here and you will create an extensibility support request to document exactly what area of the application you need to be extended or added or delegate, whatever you need that is the additional extensibility piece that you need for your solution. So when you come in here to the LCS extensibility request tool, you would define your type of request, and there's the list of types there within LCS. I would caution you to be careful of intrusive changes, as we were just talking about, as these are less likely to be accepted. Think again about how your extensibility request could be additive to the solution and not break the overall extensibility model. So to this end, one of the managers for the extensibility team wrote a very good blog that talks about kind of tips on logging extensibility requests and what they see as sort of what are the most successful extensibility requests. I've kind of summarized those here, but the blog post is there at the bottom. But one of the first things is that you do need to make sure that you are ready with your extensibility request. Simply taking your AX 2012 code base and assuming that every place that's overlayered means an extensibility request, those are not the same things. You do need to go through, look to see, are there chain of command features? Are there already delegate requests in place? Are there eventing sources? There might be, like we said, what we have seen is that probably 80% of your overlayered code can be simply moved over to the existing technology that we have. Make sure that you are using the most current version, as of right now, the 8.1 release, and make sure that you have the most recent month release even on that, so that you're not making a duplicate request that would just sort of, just get rejected. Make sure that you're on the most current release and that you are seeing, you are not seeing the extensibility feature that you need in that most current release. Obviously, understand the extensibility features that are available, such as what we've talked about in this tech talk. Make sure you understand how extension classes work, how chain of command works, how delegates work, and the various metadata extensibility features that already exist. Beware, as I was saying, beware of requesting intrusive changes. One thing that I intentionally did not talk about in this talk is the replaceable attribute, as it has been requested a lot in terms of something that you can apply, that the Microsoft code can apply, that then could skip the next call for chain of command. And this is something that is very dangerous, seen as essentially bringing back overlayering into the core application. And so it's something that we are very much not likely to approve as an extensibility request. And then finally, for the team to really understand what the ask is, it helps to understand the business scenario. And so documenting as much of that you can in those extensibility requests really does help the team in terms of understanding what you're going for there. All right. So that is the end of my presentation. Thank you very much for listening.
All right, thank you, Zach. All right, ladies and gentlemen, I'd like to take a brief moment and bring your attention to a link that I posted in the conversation window. That's a link to a short survey for this web conference, and we ask that you please take a moment before logging out to access it. We hope that you found today's information helpful, and if you enjoyed today's web conference, have feedback on how we can provide you with a better event, or you would like to submit topics for future web conferences, this is your chance to let us know. The survey scores are on a scale from 1 to 5, with 5 being the highest score possible. And that is going to conclude today's web conference. Attendees can access the web conference recording via the same registration link used to attend today's live broadcast. I'd like to extend a big thank you to our presenter, Zach, and thank you, audience, for logging in and joining us today.